Oh, hello everyone, I'm Himanshu Asnani from Department of Mechanical Engineering and I'm here to discuss with you on a subject material science. The subject code is ME4207 and unit 4, that's number 27. Today's topic are non-ferrous metals and aluminum alloys. So the objective for today is to provide the students with a basic understanding of non-ferrous metals and aluminum alloys. The outcome after today's lecture will be the students have learned the basics of non-ferrous metals and their properties, and students have understood various types of aluminum alloys and their compositions. So now let's start with the non-ferrous metals. Okay. See, in the industries, we encounter various kinds of materials. Some are metals, some are non-metals, some are ferrous metals, some are non-ferrous metals. Okay. So now we are discussing about non-ferrous metals. So these non-ferrous metals are those which contain a metal other than iron. Okay, as their chief constituents. But means iron is not present there. These are those metals which contain a metal other than iron as their chief constituents. So non-ferrous metals are usually employed in industry due to following characteristics like ease of fabrication, or like for a casting, or rolling, forging, welding, and machining. These all are fabrications. So these non-ferrous metals, they have ease of fabrication and then resistance to corrosion. Okay. Third point, electrical and thermal conductivity and fourth is the weight. Okay. Now the various non-ferrous metals used in engineering practice are like aluminium and copper, lead, tin, zinc, nickel, etc. and their alloys. So in the diagram bottom, in the bottom you can see that the five kinds of non-ferrous metals are shown, like copper is shown, brass is shown, aluminum is shown, tungsten is shown, lead is shown. See, these are for us for information. Okay, these things. So let's go further. Step. Now, non-ferrous metals. These are alloys or metals that do not contain any appreciable amounts of iron. Okay. All pure metals are non-ferrous elements except for iron, which is also called ferrite from the Latin ferrum, means iron. So non-ferrous metals just tend to be more expensive than ferrous metals, but are used for their desirable properties, including lightweight, example aluminium, high conductivity, example copper, non-magnetic properties, or resistance to corrosion like zinc. So you can see that the non-ferrous metals, these have various applications due to their desired properties. Okay, like for example, if you take for aluminium, so aluminium is famous for the lightweight. Okay, then if you go for the copper is famous for the high connectivity. And if you go for the zinc, then it has the non-magnetic properties or resistance to corrosion. Now, okay, so this is really important. So some non-ferrous materials are used in the iron and steel industries, such as bauxite, which is used in blast furnaces. And other non-ferrous metals include chromite, pyrolusite, and wolframite are used to make ferrous alloys. Okay. Now, however, some non-ferrous metals have low melting points, making them less suitable for applications at high temperature. Okay. So the main important thing that these non-ferrous metals, these are alloys or metals that do not contain appreciable amounts of iron. Now, that is the thing that we should understand and remember. Okay. Now, there are a large number of non-ferrous metals covering every metal and alloy that does not contain iron. So non-ferrous metals include aluminium, copper, lead, nickel, tin, titanium, and zinc, as well as copper alloys like brass and bronze. See, in the industry, these two materials, brass and bronze, have a wide application. And from this statement, we understand that these all are copper alloys. Okay, so some of the non-ferrous metals that include are like aluminium, copper, lead, nickel, tin, titanium, and zinc, as well as copper alloys like brass and bronze. Other rare or precious non-ferrous metals include gold, silver, platinum, cobalt, mercury, tungsten, beryllium, bismuth, cerium, cadmium, niobium, indium, gallium, germanium, lithium, selenium, tantalum, beryllium, vanadium, zirconium. Okay, so these are some rare and precious non-ferrous metals. Okay, out of them, gold and silver are and platinum. These are commonly used. Okay, mercury is also very easily available. Tungsten we use in most common in our workshops also. Okay, we have tungsten. So these are some precious non-ferrous materials. Okay. Now, non-ferrous metals are usually obtained from minerals like carbonates or silicates, sulfides before being refined through electrolysis. What they say, these non-ferrous metals, these are usually obtained from minerals like carbonates, silicates, and sulfides before being refined through electrolysis. So the difference between ferrous and non-ferrous metals is that ferrous metals these contain iron, and ferrous metals such as cast iron or carbon steel have a high carbon content. Okay, these have high carbon content, which generally makes them vulnerable to rust, which when exposed to moisture. They say the difference between ferrous and non-ferrous metals is that the ferrous metals these contain iron, and ferrous metals such as cast iron or carbon steel. Okay, these have high carbon content, which generally makes them vulnerable to rust when exposed to moisture. However, this is not the case for wrought iron, which resists rust due to its purity. Wrought iron it resists rust due to its purity, and stainless steel, which is protected from corrosion by the presence of chromium. Chromium is an element that we add in this stainless steel, okay, to provide corrosive properties to that. Okay, so you can see that these non-ferrous metals these are usually obtained from minerals like carbonates, silicates, and sulfides, okay, before being refined through electrolysis. These are also very important. Okay, now, the non-ferrous metals and recycling. Okay, so the non-ferrous scrap metals are usually recycled and have formed an important part of the metallurgy industry. Okay, where new metals are produced using scrap materials. Where new metals are produced using scrap materials. This can include resmelting or recasting non-ferrous metals. So recycled non-ferrous metals are sourced from industrial scrap materials, scrap technology such as copper cables, and even particle emissions. So we understand that how the recycling process is done. Okay, because you know that recycled materials or recycled you can say scraps. Okay, metal scraps. It can be non-ferrous scrap metals or it can be ferrous scrap metals, whatever. These are a very important part of the metallurgical industries because these help to find out some new materials using the scrap materials. Okay. Now the processes do this that this include re-smelting and recasting of these non-ferrous metals. Okay. Now these recycled non-ferrous metals these are sourced from industrial scrap materials or scrap technologies such as copper cables, very commonly available, and even particle emissions. Okay. Now the uses and properties. Now non-ferrous metals are used for a wide range of commercial, industrial, and residential applications. Okay, and this may require careful material selection according to their mechanical properties. What this may require careful material selection according to their mechanical properties, including how easily the metal can be shaped and whether these properties will be altered in the process. Okay. Now, many of the properties of ferrous metals can be found in non-ferrous materials. For example, aluminium or titanium alloys can replace steel in some instances, and the magnetic properties of iron can be emulated by cobalt, nickel, or rare earth elements that have been alloyed. Now, this is like something you can say a new invention in the field of materials. They say that many of the properties of ferrous metals, this can be found in non-ferrous materials also. Okay. Now, like they give an example of like aluminium or titanium alloys. Okay, these aluminium or titanium alloys can replace steel in some instance. Okay, and the magnetic property of iron. Okay, this can be emulated by cobalt, nickel, or rare earth elements that have been alloyed. Okay, now this is how they are doing. They are finding out new materials that can help to replace steel also. However, because non-ferrous metals are often more expensive, they tend to be used for their unique attributes rather than simply as a replacement for steel. Okay. Now this is one of the important point because you think that everything the cost matters, and if something is expensive, then it should be used very cautiously. So they say that these non-ferrous metals, these are very expensive. So they are used for their unique attributes rather than simply as a replacement for steel. Okay. Now these attributes include lighter weights and conductivity and corrosion resistance and non-magnetic properties, which are really important when you think from applications point of view. Then these features or attributes like lightweight, conductivity, corrosion resistance, non-magnetic properties. These are really important. Okay, these features are really important. These properties, or you can say attributes, whatever, these are really important. Okay, when you talk about the from application point of view. So non-ferrous metals also tend to be softer and more malleable than ferrous metals. Okay, non-ferrous metals they also tend to be softer and more malleable. Okay, than ferrous metals, meaning that they can also provide aesthetic applications as with gold and silver. Okay, see, understand that the materials, okay, why we are finding that materials because of its applications. Applications may be commercial, industrial, or residential applications. Okay, so we should we should be careful select the material according to the properties. Okay, because like how easily the metal can be shaped or whether these properties will be altered in the process or not. So if we talk about non-ferrous materials, non-ferrous materials, they are, you can say, lighter in weight and they have good conductivity and they have good corrosion resistance and they are non-magnetic, they have also have non-magnetic properties. So these non-ferrous materials or metals, sorry, non-ferrous metals, they also tend to be softer and more malleable than ferrous metals, meaning they can also provide aesthetic applications as with gold and silver. So some properties of non-ferrous metals. Okay. Now let's come to the property portion. Easy to fabricate, like including machinability, casting, and welding. Okay. Then high corrosion resistance, obviously. Then good thermal and electrical connectivity. Okay. Then low density. Then non-magnetic and colorful. You can see in the diagram on the bottom side the various colors, the range of colors it is giving you. Like copper is shown in a different color, and brass is in a different color. Aluminum is also in a different color. Tungsten is in a different color. Lead is in a different color. So you have seen there the variety of colors that these non-ferrous metals are having with them. Okay, so now non-ferrous metals and castings. Now, metals, both ferrous and non-ferrous, these can be cast into finished part or cast into an intermediate form like an ingot before being extruded, forged, rolled, wrought, or worked into the desired shape. Okay. Now, the reaction to non-ferrous metals to these processes is more severe. What do they say? This reaction to non-ferrous metals to these processes is more severe than with ferrous metals, meaning that the properties of the cast or wrought forms of the same metal or alloys may differ. Now let me make you understand the statement. The reaction to non-ferrous metals to these processes is more severe than with ferrous metals. Understand? The non-ferrous metals, these are more severe than with ferrous metals, meaning that these properties of cast or wrought forms of the same metal or alloy may differ. It is important to choose the right metal to balance performance with aesthetics, as this may influence production methods. You have to choose the right metal to balance performance with aesthetics, as this may influence the production method. So while ferrous metals tend to choose for casting, non-ferrous metals can also be chosen for properties such as corrosion resistance, lack of magnetism, and or weight rather than tensile strength. Okay, now this is now from you can say uh, production point of view. Like ferrous metals, they tend to be chosen for castings. Okay, but non-ferrous metals can also be chosen for properties such as corrosion resistance, lack of magnetism, weight rather than tensile strength. So materials like brass or bronze that we just discussed before, these are copper alloys, may also be chosen for appearance or tradition. Okay, now this is a good application of brass and bronze. Okay, now some common non-ferrous metals and alloys. So we have discussed so far in our previous slides. So what all kinds of non-ferrous metals are there? We have named a few, obviously, but now we are discussing 2 3 points on each non-ferrous metal. Okay, because we need to understand, we need to know. Sorry, we need to know that what all are the features of each non-ferrous metal possible. Okay. Then afterwards we will be discussing about the alloys, these non-ferrous metals these give you. Okay, then let's start with it. Then because they include and some common non-ferrous metals and alloys, because they include any metal that doesn't include iron, there are lots of different okay there are lots of different non-ferrous metals and alloys. Here are some of the properties and common uses of some or more non-ferrous metals. Okay, now first of all, let's start with the copper. Okay, having seen by the humans for thousands of years, copper is still widely used by industry. The addition of copper alloys like brass, that is copper and zinc, and bronze, that is copper and tin, have widened the use for this non-ferrous metal further. Okay, we know that in the industry, this brass and bronze. Brass is an alloy of copper and zinc, and bronze is an alloy of copper and tin. Okay, now these have wide uses in the industry. Okay, so this non-ferrous metal is really used in the industry. Okay, by for many years previously also, and for the present in the present condition also. Now the properties of copper and its alloys. These properties of copper and alloys. These include high thermal conductivity and high electrical conductivity, good corrosion resistance, and high ductility. Now they say that the properties of copper and its alloys these include high thermal conductivity and high electrical conductivity. This is really good and good corrosion resistance that is we really need and high ductility. Sorry. Okay, so these properties have allowed copper and its alloys to be used for heat exchangers and heating vessels. Okay, as an electrical conductor in wiring or motors. Okay, we also know that the copper normally is used in wires. Okay, so these properties, the properties like high thermal conductivity, high electrical conductivity, good corrosion resistance, and high ductility, these have helped or you can allowed copper and its alloys to be used for heat exchangers and heating vessels as an electrical conductor or in wirings or motors. So as a roofing material and for plumbing fittings as well as for saucepans and you can say statues. Okay, so copper also oxidizes to a green color. So this is really important. This copper it also oxidizes to a green color. Now to aluminium. So aluminium is an important metal that is used in a wide range of applications due to its low weight. Okay, aluminium is an important metal that is used in a wide range of applications due to its low weight and ease of machining. Now, this is really good property that is having low weight and that is having ease of machining. Despite being a relatively expensive material, aluminium is also a base metal for many alloys. Okay, so you might also be studied about aluminum alloys in our workshop also, where we have discussing aluminum combination with various other elements in the materials. So you can understand that despite being a relatively expensive material, aluminum is also a base metal for many alloys. So being corrosion resistant and a good conductor of heat and electricity, as well as good ductility and malleability, aluminum can require annealing as it becomes hard following cold working. Okay, so you can see the amount of features or you can say properties or attributes this aluminium non-ferrous metal is having. They say that being corrosion resistant and a good conductor of heat and electricity as well as having a good ductility and malleability, aluminum can require annealing as it becomes hard following cold working. So this lightweight of aluminium makes it perfect for aerospace and automotive applications as well as for marine use in yachts. So aluminium is also found in bicycle frames, in saucepans, in drink cans. Okay, these drink cans these are commercial applications. You also know. Okay, you can understand the wide range of applications this aluminium has, like aerospace, automotive applications. Okay, very mainframe applications are like wow. Okay, secondly, the amount of the properties which is having like corrosion resistant, good conductor of heat and electricity, good ductility, good malleability. Okay, so this is really good. But despite of all these, it is expensive material. Okay, but so it is used as a base metal for many alloys if possible. Now lead. Now, this is also very important non-ferrous metal. They say that lead has been used for over centuries for a range of applications, including for bullets, in fuels, and even in paints. However, it was found to be unhealthy when released into the atmosphere, while other applications also cause harm to others. So we knew that the lead obviously is used in bullets, okay, and paints also, and somehow a small quantity in fuels. So we knew that the this uh, exposure of this lead, which is unhealthy, okay, when you release it in the atmosphere. And secondly, the applications obviously in which it is used also cause harm to others. So lead is the heaviest common metal and is resistant to corrosion. So it does not react with many chemicals and is soft and malleable. Okay, this does not react with many chemicals and is soft and malleable. So although many of its former uses are no longer allowed, the lead is still widely used for batteries, power cables, and acid tanks. So this has a wide applications also. Now zinc. Zinc has also been used for centuries as an alloying element, particularly to alloy steel for a range of purposes as well as for alloying copper and to create brass. Okay, this is very important. A galvanizing material with alloying elements offer them a great resistance to rust, affording it uses for chain-like fencing, guardrails, suspension bridges, lamppost metal roofs, heat exchangers. You can see the the applications the zinc has. Okay, so they say that you can zinc. You can see the copper alloy, a common name as brass, copper plus zinc. So it's also given its applications with copper also as brass. So you can see the galvanizing materials with alloying elements. These offer a great resistance to rust and affording it uses for chain-like fencing, guardrails, suspension bridges, lampposts, metal roofs, heat exchangers, and cardboard. So zinc is also used as a sacrificial anode in cathodic production. Okay, so this is sacrificial anode in cathodic production and as a anode material for batteries. Zinc oxide is also used as a white pigment in paints and to disperse heat during rubber manufacture. This zinc is used to disperse heat during rubber manufacture. This is also very good when you so it has application in paint also and in rubber manufacturing also. So it's really you can say a nice application. Now silver. The silver has been used as a precious metal for centuries with the highest electrical connectivity, thermal conductivity and reflectivity of any metal. Silver is so soft and malleable when heated and is highly resistant to corrosion. So used for jewelry and currency, silver can also be found being used in solar panels. Okay, this is used in jewelry and currency is very known. Now this can also be used in solar panels for water filtration, electrical contacts and conductors, as well as sustained glasses and even in specialized manufacturing. So you can understand that this property of silver is that it is soft and malleable when heated. Okay, and it is also resistant to corrosion. So it is also used in jewelry and currency. Okay, and it has also been found its applications in solar panel also for water filtration, electrical contacts and conductors, as well as for stained glasses and even in specialized confection. So silver is also used it has wide applications also. Now, gold, another precious metal that has been used for jewelry and coinage. Okay, gold is the most malleable of metal as well as most ductile, being ductile and resistant to corrosion and many other chemical reactions. We understand that gold, we say that is the most malleable of metals as well as being ductile and resistant to corrosion and many other chemical reactions. So its electrical conductivity that has been used, that has been gold since you can say used in computer devices as well as for infrared shielding, for the production of colored glass or for gold leaf and also for tooth restoration. Somehow then people use gold for tooth restoration also, and somehow they use for production of colored glasses also. So it has its own, you can say, uses. Okay. So because due to its electrical connectivity, this has made use of gold used in the computer devices also. So titanium, let's go to the titanium. So titanium was discovered in 1971 and offers good corrosion resistance and has the highest strength to density ratio of many metallic elements, alloyed as it is strong as some steels yet less dense. Okay. So it can be alloyed with metals including iron and aluminum to create strong yet lightweight alloys for aerospace, automotive, agriculture, military, medical and sporting uses as well as used for jewelry and mobile phones. Titanium is also having a very wide application. Now alloys. The alloys mix a metal with an element to improve the properties or aesthetics, such as brass, which is a mixture of copper and zinc. So alloys can be either ferrous or non-ferrous in nature, although non-ferrous metals may require finish as protection or to improve the appearance of an alloyed product. So common non-ferrous alloys, these include brass and bronze, okay, which have been cast since the Bronze Age. So these alloys melt at lower temperatures than ferrous materials and cast well, making them ideal for decorative applications. So despite being softer than steel, brass and bronze are both corrosion resistant even in the presence of and so are widely used for fittings on boats. Brass is also resistant to wearing when the metal wears itself against itself. Now this means that the brass can now be used for mechanical parts and machine to create items including locks and bearings and zippers. The bronze is harder than brass, so although both are quite expensive, they are there as they rely on copper. Okay, so copper is obviously costlier, so these two are expensive also. Now brass is created as an alloy of copper and zinc, while bronze is an alloy of copper with aluminium or nickel. So further. People have been using various non-ferrous metals for different uses for thousands of years. The applications for these versatile materials range from decorative uses through to through to electronics, aerospace, and beyond. So non-ferrous metals, while able to mimic the attributes of some ferrous metals, are usually chosen for their own unique attributes. These attributes include lightweight, non-magnetic properties, and corrosion resistance. These metals will tend to be more malleable than ferrous metals, allowing them for decorative purposes such as in jewelry or for making statues. You can see the applications are so wide when we talk about these non-ferrous metals. Okay, so now let's discuss a deeper mode on aluminium. Okay, and aluminum alloys. Yeah, you can see in the diagram. This is the part of the engine. Okay, that is made up of. So this also aluminum can be used. So it is a white metal that is produced by electrical processes from its bauxite alumina, which is prepared from a clay material mineral called bauxite. So it is a light metal having specific gravity around 2.7 and melting point of 58 degrees centigrade. The tensile strength of a metal varies from this 90 MPa to 150 MPa, and in its pure state, the metal would be weak and soft for most purposes. But when mixed with small amounts of other alloys, it becomes hard and rigid. Okay, in its pure state, this metal, this aluminum, is weak and soft for most purposes. Okay, but when small amounts of other alloys are mixed in it, it becomes hard and rigid. So it may be blanked, formed, drawn, turned, cast, forged, and die cast. Okay, so its good electrical connectivity is also an important property and is widely used for overhead cables. Okay, this aluminum it has good electrical conductivity, and only for this reason it is widely used for overhead cables. So the high resistance to corrosion and its non-toxicity makes it a useful metal for cooking utensils under ordinary conditions, and thin foils are used for wrapping food items. Now this is also used in thin foils also. Okay, and somehow some people still use cooking utensils made up of aluminium. Okay, and one of the important thing that it has high resistance to corrosion. This aluminium, this material has a high resistance to corrosion. So these make them very applicable in the industry. It is extensively used in aircraft and automobile components where saving of weight is an advantage. Obviously, it has this application in aircraft and automobile components. Okay. Now, in construction, what we talk about in construction, the aluminum and some of its alloys offer a very suitable alternative material to steel in some spatial engineering constructions. Like thus, wrought aluminum alloys are economical, they are resistant to corrosion, and light in weight. What? They are economical, resistance to corrosion, and light in weight. So compared to steels, they have been used in construction of bridges and roofs in situations where not much strength is required. So in these situations, they have been found to save 50% by extra weight. Okay, they are able to save around 50% of extra weight in these cases due to its properties like resistance to corrosion and light and weight. Okay, so this is appreciable. Okay, this is really appreciable. Now some properties of aluminium in short that we are discussing. Mhm. Now following are some properties of this metal. Like it is a silvery white metal and shows brilliant luster when fresh. This also we know that obviously this aluminum it is a silvery white metal, okay, and it shows brilliant luster when finished. It is an excellent conductor of heat and electricity. Okay. It is light in weight, then with a specific gravity of around 2.7. It is a good reflector of light. It is non-magnetic and high resistance and high resistance to corrosion. It is non-magnetic and has high resistance to corrosion. It is soft, tough, malleable, and ductile. It is very ductile and can be transformed into any shape by rolling, stamping, extruding, forging, drawing, spinning. Its melting point temperature is about 650 degrees centigrade. It has high tensile strength. It can also be cast into any shape by any method of casting like die casting or sand casting. Okay, it is resistant to organic acids. Okay, it's resistant to organic acids and salt solution, etc. It can cell strength of about 900 kg per square centimeter. In the annealed condition, it can be improved to 1600 kg per centimeter square by hard rolling method. So these are some properties of aluminium which has given its applications in the industry, in the mechanical industry, in the construction industry. You can see how valuable this aluminium is. The use of aluminium that is used in the manufacture of equipment for chemical and food industries, cooking utensils, cookers, steam jackets, kettles, etc. Due to its light weight and high tensile strength, it is used in structural work of airplanes, ships, trains, buses, trucks, etc., and used for roofing, shelving, window frames, foils, posts, etc. And is used for manufacturing of electrical cables. Okay, so in cables also we use aluminium some in some cases. Okay, now used for manufacturing of reflectors and mirrors. That we know, aluminum powder used for preparing paints, and since used in iron and steel for making as a deoxidizer. So this the use of aluminum are also very wide. Now some aluminum alloys. Now aluminum may be alloyed with one or more elements like copper and magnesium, manganese, silicon, nickel. Okay, some elements like copper, magnesium, manganese, silicon, nickel. These can be added. Now the addition of some small quantities of alloying elements it converts the soft and weak metal into hard and strong metal while it's retaining its light weight. Now this is one important thing that is very important when we talk about aluminum alloys. These aluminum can be alloyed with one or more elements like copper and magnesium, manganese, silicon, nickel, and the addition of these small quantities of alloying elements to convert the soft and weak metal into hard and strong metal. But what happens? What happens that this alloying elements they convert the soft and weak element into hard and strong metal. But the weight of the alloy of the aluminum is still lightweight. So the main aluminum alloys are like first is duralium. So it is an important and has an interesting wrought alloy. Its composition is as follows like copper is 3.5 to 4.5%, manganese is 3.4 to 0.7%, magnesium is 0.4 to 0.7%, and the remainder is aluminium. Okay. Now this alloy possesses maximum tensile strength and after heat treatment and heat hardening. So after working, if the metal is allowed to age for 3 or 4 days, it will be hardened. So this phenomenon is known as age hardening. Now it is widely used in wrought conditions for raw forging and stamping bars, sheets, tubes, rivets. It can be worked in hot condition at a temperature of 500 degrees centigrade. However, after forging and annealing, it can also be cold work. Okay, after forging and annealing, it can also be cold work. So due to its high strength and light weight, this alloy can be used in automobile and aircraft components. And it is also used in manufacturing, okay, connecting rods, bars, rivets, pulleys, etc. So you can understand the applications are also very wide of this uh, beryllium alloy. Okay, this is an aluminum alloy named as beryllium. The composition is like copper is having 3 to 5.5 to 4.5%, and manganese is 0.4 to 0.7%, magnesium is 0.4 to 0.7%, then remainder is aluminium. And this beryllium is having high strength and lightweight, and it is due to this high strength and lightweight, this alloy is used in automobile and aircraft components. It is also used in manufacturing of the connecting rods. Okay, bars, rivets, pulleys, etc. Okay, so it is used in pulleys also. The pulley is also very good application. Then why alloy? It is also called as copper aluminium alloy. Okay, the addition of copper to pure aluminium increases its strength and machinability. Okay, what happens? The addition of copper to pure aluminium increases strength and machinability. Now in this, what happens? The copper is around 3.5 to 4.5%. Magnesium is 1.2 to 1.7%. Nickel is 1.8 to 2.3%. Silicon, magnesium, okay, iron is 0.6% each. And okay, then silicon, magnesium, iron, these are 0.6% each. And the remainder is aluminum. You can see the composition is also very vast in this case. Like copper is from 3.5 to 4.5%, magnesium 1.2 to 1.7%, nickel 1.8 to 2.3%. Okay, and then silicon, magnesium, and iron, these are having 0.6% each, and remainder is aluminium. So this alloy is heat treated and age hardened like uranium, and the aging process is carried out at a temperature of about 5 days. Okay, now it is mainly used for cast purposes, but it can also be used for forged components like uranium. Okay. Normally we go for it's used for cast purposes, but it can also be used for forged components like uranium. And since Y alloy has better strength than uranium at high temperature, therefore it is used much in aircraft engines for cylinder heads and pistons due to its applications at high temperatures. Okay, so I want to just make you just remember the composition of this alloy. That is, it is the my alloy has copper in it. It is copper from 3.5 to 4.5%. The copper is important. Manganese 1.2 to 1.7%. Nickel 1.8 to 2.3%. Silicon, magnesium, sorry, silicon, manganese, and iron at 0.6% each, and the remainder is aluminium. Okay. Now magnesium. It is made by melting of the aluminium with 2 to 10% magnesium in a vacuum and then cooling it in a vacuum or under pressure of 100 to 200 atmosphere. It also contains about 1.75% copper. Okay, this magnesium also has copper in it. Okay, due to its lightweight and good mechanical properties, it is mainly used for aircraft and automobile components. Now, hindium. It is an alloy of aluminium and magnesium with a small quantity of chromium. So its trade name of aluminium alloy produced by Hindustan Aluminium Corporation Limited. Limited. Okay. Now it is produced as a roll product in 16 gauge mainly for anodized utensil manufacture. So you can see these alloys are very widely used. Okay. So out of these all, you say these alloys that we have discussed, okay, then we can see that this Y alloy, this is having the sustainability or better strength at high temperature. Okay, that's something is useful for aircraft engines, for cylinder heads and pistons. Okay, now let's get to the another, you can say, alloy, that is copper. So copper, as you can see in the figure, how the copper looks. Okay, now it is one of the most widely used non-ferrous metal in the industry. Okay, it is soft, it is malleable, it is ductile material with a reddish brown appearance. So specific gravity is around 8.9 and melting point is around 1083 degrees centigrade. So this is really important. This and melting point is 1083 degrees centigrade. So the tensile strength which varies from 150 MPa to 400 MPa. Now this is different from aluminium if you see under different conditions. So it is a good conductor of electricity also. Okay, it is a good conductor of electricity. It is widely used in making electrical cables and wires for electrical machinery and appliances, in electrotyping, in electroplating, in making pencils. It may be cast, forged, rolled, and drawn into wires. Okay, which is non-corrosive under ordinary conditions and resist weather very effectively. Okay, so copper in the form of tubes is widely used in mechanical engineering. It is also used for making ammunition. So it is used for making useful alloys with tin, zinc, nickel, and aluminum. With aluminium, when you studied about aluminum alloys, you have seen that copper was almost present in many of the aluminum alloys. So you can see that copper has its also role with aluminium. Okay, so this non-ferrous metal, it has wide applications in the industry. Okay, although its melting point is also higher than aluminum, that is 1083 degrees centigrade, so which is also very important. Okay, and moreover, it has its applications in the electric cables and wires. Okay, due to its good electrical, you can say connectivity. So I think that this copper is really a good non-ferrous metal, important non-ferrous metal. Okay, and one of the most thing, it is non-corrosive under ordinary conditions. So this is also really good. So let's start with the MCQs if possible. The first MCQ for today is non-ferrous metals are those which contain a metal other than iron as the chief constituent. So what do you call this? Is this true or false? Okay, we know that these non-ferrous metals, they don't have iron. Okay, so this is like non-ferrous metals are those which contain a metal other than iron as the chief constituent. It is true in this case. So non-ferrous metals, uh, these tend to be more expensive than ferrous metals, but are used for their desirable properties, including a lightweight, like for aluminium, high conductivity, that's of copper, and non-magnetic properties or resistance to corrosion, that is zinc. We have discussed this in the starting also. These non-ferrous metals, these are expensive when you compare with the ferrous metals. Okay, and the properties or attributes like lightweight and high conductivity, non-magnetic properties or resistance to corrosion, uh, these attributes make them in demand in the market. So for that reason, these are expensive. Okay, so I think that this statement is true in this case. This statement is true, and the answer is A. The properties of copper and its alloy include high thermoconductivity, high electrical conductivity, and good corrosion resistance and high ductility. Now, this copper, I know it is one of the most widely used non-ferrous metal from the industry. Okay, and obviously it will have some attributes that is making them in demand in the industry. So attributes like high thermoconductivity, high electrical conductivity, good corrosion resistance, high ductility, these are very required attributes for a material. And if these attributes are there in the copper, then the statement is true. The statement is true in this case. Answer is A. The light weight of aluminium, it makes it perfect for aerospace and automotive applications. What happened? The light weight of aluminium, it makes it perfect for aerospace and automotive applications, as well as it's for marine use in much. So aluminium is found in bicycle frames, saucepans, and drink cans. Okay, so this is really good that the application of aluminium is very wide. It is true in this case. The answer is true. So duralium, one of the important one of the important aluminum alloys. So it is an important and interesting wrought alloy. Its composition is as follows: that copper is 3.5 to 4.5%, manganese 0.4 to 0.7%, magnesium is like 0.4 to 0.7%, and the remainder is aluminium. Now this alloy possesses maximum tensile strength up to this after heat treatment and age run. So I think it's true. It's true in this case. We have discussed about this aluminum alloy in detail in our slides also. It is true in this case. Now why alloy? Why alloy? This is also an aluminum alloy. Okay. So it is also called as copper aluminum alloy because it has addition of copper in it. So the addition of copper to pure aluminum increases its strength and machinability. The addition of copper to this pure aluminum, it will increase its strength and machinability. So the composition of this alloy is as follows: like copper is 3.5 to 4.5%, manganese 1.2 to 1.7%, nickel 1.8 to 2.3%, and silicon, magnesium, iron 2.6% each, and the remainder is aluminum. Okay, the composition is like copper 3.5 to 4.5%, manganese 1.2 to 1.7%, nickel 1.8 to 2.3%, silicon, magnesium, iron each for 0.6%, and the remainder is aluminum. Okay, they see that silicon, magnesium, and iron are 0.6% each. So I think it's true. Okay, it's true. It is also a very important aluminum alloy. Why alloy? Now, while alloy has better strength than beryllium at high temperatures, therefore it is much used in aircraft engines for cylinder heads and pistons. So it is true. Now, magnesium, okay, it is made by melting the iron with 2 to 10% magnesium, okay, and a vacuum, and then cooling in a vacuum or under pressure of about 100 to 200 atmosphere. It also contains 1.75% copper. So it is true. Now, Hindalium, one of the important aluminum alloy, it is an alloy of aluminum and magnesium with a small quantity of chromium. That is also true in this case. Now, melting point of copper is 1083 degrees centigrade. Oh, if we compare this with the melting point of aluminum, I think the melting point of copper was more. Okay, okay. So I think it's true. Melting point of copper is around it was more than 1000 degrees centigrade, so it's around 1083 degrees centigrade. So I think it's true in this case. Melting point of copper is 1083 degrees centigrade. It's true in this case. Answer is true A. Okay, so we have finished our MCQs and these are the references. Please refer these references, increase your knowledge in these topics. These topics are really good and wide applications in the industry. Go and study these references, have more diagrams, understand them. Okay, and by reading these books, obviously you will enhance your knowledge. Okay, so do refer these references for better, you can say, or you can say for enhancing your knowledge. Thank you.